Hi, this is Jason Baker, and welcome back to our lecture on serverless and Lambda functions. I'm going to wrap up the lecture by talking about AWS Serverless Application Model. AWS Serverless Application Model, or otherwise known as SAM, is basically an extension to CloudFormation. Now, we've been using CloudFormation quite a bit in this course. And when CloudFormation was originally designed, it was intended to orchestrate traditional AWS resources, things like VPCs, networking, compute, and storage. And then over time, AWS has evolved these different serverless resources and components. And the serverless resources don't fit as well in the traditional CloudFormation template model. And that's because oftentimes serverless resources have different sorts of dependencies. And so while you could build all of these serverless components in CloudFormation, it's easier to build the serverless components using the SAM extension. So AWS has built an extension onto the CloudFormation template that allows you to easily create serverless resources. And you can use the SAM extensions to create things like Lambda functions and API gateways, DynamoDB, and set up all the event sourcing that connects these different resources together. So let's take a look at an AWS SAM template. If you look at a SAM template, you know that it has the serverless extensions in place because at the very beginning of the template, it will have a transform attribute. And that transform attribute is set to a version of the serverless template. So you can see in this template below, which is in YAML format, you can see this transform attribute added to the template. When CloudFormation sees that transform attribute, then it knows that this particular template is using the SAM extension. It's really common, by the way, for CloudFormation SAM templates to use the YAML format. It seems to be more common than JSON, although you can create a SAM template in either format, YAML or JSON. I just wanted to point out that YAML was it's more common to find examples that are using YAML. The SAM extensions add a couple different things to your typical CloudFormation template. There's a new globals section that's available to you. And in the globals section of the template, you can define properties which are common to different resources within the template. For example, you can specify properties which are common to all of the Lambda functions within the template, or properties that are common to all of the API gateways that are defined in the template. This is so think of these as being sort of like global variables that affect the configuration of resources within the SAM template. We also have a couple new resource types, and I'll just cover a few of them here in this video. There's a new AWS serverless function resource type, and this allows you to create Lambda functions, specify the Lambda function execution role, and set up all of the event source mappings for the Lambda function. Now you could do all of these things using the traditional CloudFormation resources. So if you look at the set of CloudFormation resources that are available, you'll see a Lambda function resource. but that resource is different from this one. This serverless function resource is basically automating uh, many different configuration components with respect to the Lambda function. In particular, it's letting you set up things like the event source mapping for the Lambda function. You can see an example of the serverless function below. And here we're setting up a resource called my Lambda function. It's a serverless function, and we are specifying a set of properties. Here you see just one property list, which is the memory size. Now, this isn't a complete working example of a serverless function. You would need to specify more properties. But this is in YAML format. This is kind of giving you an idea of how the Lambda function is set up. If we look at the next slide, then you see the additional properties that you might set on the Lambda function, such as the handler in the runtime environment for the function, the timeout value. Here we're specifying the Lambda function execution role. So we're specifying the policies that are associated with the Lambda function execution role. The nice thing is that with the SAM extension, I don't have to go and create a separate IAM role resource and attach policies to it and then associate it with my Lambda function. I can define my Lambda function and just specify the policies that Lambda function will use. And what will happen is that the CloudFormation will automatically create a corresponding IAM role with the specified policies associated with it for me. You see an events property where I'm creating an event source for the Lambda function. In this case, the event source is called photo upload. It's an S3 event source, and it's going to use a bucket called my photo bucket. And what will happen with that event source is that anytime I add a new object to that particular bucket, it will trigger an event source and trigger my Lambda function, send an event to my Lambda function, giving me some information about the object that was uploaded to the bucket. My Lambda function then can do whatever it wants to do with that object. Maybe it wants to archive the object or create a thumbnail image or do something with it. But the point here is that everything I'm showing you could be done with traditional CloudFormation resources, but you'd have to create probably 5 or 6 different resources and set them all up and wire them together properly to accomplish the exact same thing that this single resource is accomplishing as part of the SAM extension. So the SAM extension is really giving us a shortcut way to create a whole bunch of different resources in AWS and configure them so that they all work together. You can set up all kinds of different event sources for your serverless function. On the left-hand side, I give you a list of some of the possible event sources that you can set up. On the right-hand side is an example where we're setting up an S3 event source and an API event source for a Lambda function. One of the cool things about the CloudFormation SAM templates is that you can basically store the template alongside Lambda function code. And you can reference the location of your Lambda function code within the template. For example, on my local system, I might have a Git repository, and inside that repository is my project directory, and it has a CloudFormation template, which is in YAML format, and then it has a subdirectory called my function, and that contains a Python script, which is index.py. The index.py represents my Lambda function code. So it's living my Lambda functions in a subdirectory called my function that is below the CloudFormation template. Within my CloudFormation template, then I'm using the SAM extension and I'm defining a serverless function. And one of the properties of that serverless function is the code URI. For the code URI, then I can just point it at the location of my function code, which is in the my function subdirectory. So this associates the CloudFormation template Lambda function configuration with the actual Lambda function code. And I'll show you why this is important here in a minute. Another resource that we can set up within a SAM template is a DynamoDB table. And this is called a simple table. You can set up DynamoDB tables using CloudFormation, and if you need to set up more complicated tables, you'd want to use the traditional CloudFormation DynamoDB table resource. However, if you want to set up a fairly simple table, one that has a single attribute-based primary key, then you can use the serverless simple table resource. And here's an example where we're setting up a table called my table, and or the logical name for the resource is my table, and the name of the table is my table. We don't have to give the table a name. We might want to just allow CloudFormation to dynamically generate the table name, in which case we would leave off this table name property. We would define the primary key. Remember, every DynamoDB table has to have a primary key, which could be a single partition key, or it could be a composite key, which is a partition key plus a sort key. When you're using this simple table resource, you can only use a single primary key. In this case, we're using one with an ID, a name called ID, and it's a string type. And we're using the default provisioning, which when you set up DynamoDB tables, you provision a certain amount of resources for reading and writing to the table. So in this case, we're using the default of 5 read capacity units and 5 write units. And finally, we're setting some tags on our table because, of course, it's always a good idea to tag our resources. When working with CloudFormation SAM templates, the process that you go through to deploy the template is a little bit different than a traditional template, because CloudFormation has to first evaluate and package the resources in the CloudFormation template. So what will happen is you use 2 different commands to deploy a SAM-based CloudFormation template. First, you will use the AWS CloudFormation package command to package the template. Well, what does that do? It does a couple different things. First, AWS, so the AWS CloudFormation package tool will package up all of the Lambda function code that's associated with the template. The Lambda functions, when they're packaged, they're basically just zipped up into archives. And then those archives are uploaded into an S3 bucket. So that's the first thing that the packaging command will do, is it will archive the Lambda function code scripts and upload them into an S3 bucket. The command will then basically parse and evaluate the CloudFormation template, and it will substitute the S3 bucket location of those packages into the code URI property for each of the Lambda functions in the template. So now it generates a new template version, and it's sort of a new template artifact. And it's that newly generated template that you want to deploy into CloudFormation. You do that using the AWS CloudFormation deploy command to deploy that newly generated template. And remember that new template now has references to the S3 bucket locations where the Lambda function packages are located. And we'll use both of these commands in a project and in our homework assignment this week. I'll finish up the lecture just by mentioning that there are a couple other tools available in the marketplace to build serverless applications. Of course, you can build serverless applications by writing the code and using CloudFormation SAM, or just even using a traditional CloudFormation template. Uh, you can create these resources on your own. However, if you're not really, if you're sort of a developer and you're not really strong in terms of understanding CloudFormation or how different AWS resources work, you can use a, an application framework to build your serverless application and deploy it onto AWS. The cool thing about using a framework is that it really takes care of configuring and building all of the serverless resources for your application. And it allows you as a developer just to focus on creating your application code. I recommend that you take a couple minutes and look at these two tools that I have mentioned here, serverless.com, which is an application framework that works with a number of different cloud platforms, not only AWS, but Azure, Google Cloud, and others. And then the second tool, which is Zappa, located at zappa.io. This is a Python-based serverless framework that's designed specifically for deploying AWS serverless applications. And these can be really wonderful tools if you really want to focus on building out your application and quickly deploying a new serverless application and you're accustomed to working within frameworks, then either one of these tools might be an excellent choice for you.